Today's lesson will be on classifying triangles by sides and angles and finding interior and exterior angle measures of triangles. Triangles can be classified in two ways. By the number of congruent sides, scalene has no congruent sides, isosceles has at least two congruent sides, and equilateral has three congruent sides. It can also be classified by the type of angles that it has. An acute triangle has three acute angles. A right triangle has one right and two acute angles. An obtuse triangle has one obtuse angle with two acute angles. And an equiangular triangle has three congruent angles. The triangle sum theorem tells us that the sum of the measures of the interior angles of any triangle is 180 degrees. The exterior angle theorem tells us that the measure of an exterior angle of a triangle is equal to the sum of the two non-adjacent interior angles, sometimes also referred as the remote interior angles. My example is angle 1 equals the measure of angle A plus the measure of angle B. The corollary to the triangle sum theorem tells us the acute angles of a right triangle are always complementary. So measure of A plus the measure of angle B always equals 90 degrees. Example. Classify the triangular shape of the support beams in the diagram by its sides and by measuring its angles. I have two different types of triangles, so we're classifying the triangle by sides and angles. We can see that on the first one, that two sides are marked congruent. Since two sides are marked congruent, it would be isosceles. Angles, it has three acute angles, so that would make it acute. On the second one, we can see that there are no sides marked congruent. We have to go by the marking on the drawing, so that would be scalene. Since it has a right angle marked on the picture, it would be a right triangle. So we always classify in two ways for every triangle, according to the sides and according to the angles. Classify triangle ABC by its sides, then determine whether it is a right triangle. So if we want to classify it by its sides, we're determining if it's a right triangle. We need to find the length of the sides to determine whether it's a right triangle anyways. So we can find the length of the sides using what we learned about Pythagorean theorem. Distance formula will also work. It's probably easier on these since it's on a graph to just use the Pythagorean theorem idea. So I'm going to highlight this region. This would be the hypotenuse of a right triangle, so this is a 1 by 4. So 1 squared plus 4 squared is equal to, we'll call this side x squared. 1 plus 16 equals 17. So this is the square root of 17. The other side forms a right triangle around it. That would be 7 by 2. 7 squared plus 2 squared will equal that side squared. We'll call that side y. 49 plus 4 equals 53. So this is the square root of 53. The other side of the triangle is a six by 2. I'll call that side z. 6 squared plus 2 squared equals z squared. 36 plus 4 equals 40. So z is the square root of 40. So we know that all the sides are different, therefore it's scalene. To determine if it's a right triangle for sure or not, we check to see if leg squared plus leg squared equals hypotenuse squared. So does 17 plus 46 equal 53? The answer is no, so it'd have to be acute. In our next example, the exterior angle equals the sum of the two non-adjacent interior angles. We add them together. We'll solve for x and then find the measure of angle PQS. X equals 40. Excuse me. Measure of the angle, 3 times 40 plus 25. Which equals 145. So that's the measure of my angle and the answer. In our last example, the measure of one acute angle of a right triangle, the key thing here is that it's a right triangle to begin with, is 1.5 times the measure of the other acute angle. Find the measure of each acute angle. We know that the sum of the 3 angles equals 180, tells us it's a right triangle. So we know that the other 2 angles, we'll call the first angle x. The second angle is 1.5 times that measure. The sum has to be 90 because 180 minus the 90 for the right triangle leaves us a measure of 90. That'd be 2.5x equals 90 divided by 2.5 on both sides. X equals 36. Which means the first acute angle is 36 degrees. The second one is 36 times 1.5, so 54 degrees. And that's our measure. That's all for our lesson for today.